Felix, you found the center right. Just make sure that when you write a point that you put parentheses around it. What isn't correct are these values right here, and I'm not sure how you arrived at those. You were graphing it correctly down here. The suggestion that I would use, and this is what we were working on when we did the stuff with ellipses, is to think about it in terms of completing the square. So if we were to factor out a 4 and have x squared plus 4x plus something, and then factor out a 2 over here plus 2, y squared minus 6y plus something, and then equals negative 18 plus, and then we just need to make sure that what we're adding here is equivalent to the values that we added here and here. So if we were to do that, we would get 4x squared plus 4x, completing the square, plus 4 plus 2 y squared minus 6y plus 9 equals negative 18 plus 16 plus 18. And notice it's plus 16 because it's 4 here, but there's a 4 on the outside, so we really added 16. Simplify that and then see what you get. This looks like you need to do a little bit of review on z-tests. The main idea is that we want to take some value. We want to take this 166 hours and compare it to the 155 hours in terms of how many standard deviations it is away from the mean. So the standard deviation, which you're going to write as sigma, the standard deviation for each individual object, the standard deviation is 15. But when we take a mean, the standard deviation of a mean, since we're dealing with 9 students, we would expect there to be less variation, because the more students that you're looking at, the less varied the results of the mean will be. So the standard deviation of the mean is the standard deviation over the square root times the number of the sample size. So we'd have 15 over square root 9, which is 5. And so my z value, which looks at how many standard deviations away, number of standard deviations from the mean, well, we're just going to normalize it. So we're going to say I got 166 minus the mean, so that's the difference my value is from the mean, but I want to talk about that in terms of how many standard deviations it is, so divided by 5. I think this equals 3.2, and this is the z value. So now what you need to do is figure out, you're going to need to kind of remind yourself and do a little bit of review to say, well, what does that number mean? And I would say maybe first of all, it's important to say that we needed to start with a null hypothesis, which says that the average value that we looked at equals the mean. That's the Greek letter mu for mean. And then the alternative hypothesis is that the sample mean that we got is greater than the mu. Now clearly it's greater than, 166 is clearly greater than 150, but we want to see, is it large enough that we cannot attribute it to just randomness? Okay, so for this problem here, this isn't totally right, and you're making a sloppy error. And my hint would be this: 3 plus 9 over 3. Sorry. 3 plus 9 over 3 does not equal 1 plus 9. That's the mistake similar that you're making right here. Also, I am having a hard time finding the work that you did for this. And for 18, it should be from 3 to infinity, open bracket for the infinity, but closed bracket for the 3, because it can equal 3. But the range is not correct. So for this problem, I'm not totally sure how to follow what's going on. I think that what you should do is look at law of cosines, review that, and then also review inverse trig functions, because what you've written here suggests a rather large misunderstanding in that arctan or any inverse trig function needs an argument. There needs to be something that's going in there. And what's going in there is the ratio of one side to the other, and then the inverse trig inputs here, it inputs a ratio and it's going to output the angle. So make sure that you review these, and maybe let's see if you can get this correct. Alright, so this looks good. I think for me it's really helpful to graph these functions when you're trying to think about inequalities. So because it's a polynomial of an even degree, very quickly you can get the roots. So there's one at -3, at -1, at 0, and at 1. And because it's a even degree, meaning, well, in this case it's a 4th degree, and a positive leading coefficient, we know that the graph is going to look something like that. So when is it greater than 0? It's greater than 0 from -infinity up until 3, -3, and, so that's the union sign, from -1 to 0, and, or union, from 1 to infinity. Okay, for this problem, this is a challenging problem, but you got down to an expression, and I didn't see any work for this, so I'm not really sure how you got here. This is something that really is just about slope, so maybe just as a little bit of help, we could say, just to get a sense of what this function looks like, it's a quadratic, and if we were to choose, some x value, but let's be specific, so let's use when x equals 3. So when we have x equals 3, that's going to correspond to 18. And then when we have some point that's close to it. Let's say that's 3 plus h, and the corresponding value there would be 3 plus h squared plus 3 times 3 plus h. So the slope between these 2 points would be the change in y, which is 3 plus h squared plus 3 times 3 plus h. That's the initial y value, minus 18 all over 3 plus h minus 3. And if we simplify this, or rather expand it and then simplify, we get h squared plus 6h plus 9 plus 9 plus 3h minus 18 all over h. And if we simplify this even more, we're going to get h squared plus 9h plus 18 minus 18 over h. And now we see that the 18 and the minus 18 cross off. And if we simplify, we can get that this equals h times h plus 9 over h, which equals h plus 9. But now what we want to do is we want to let h get really, really close to 0, because we want this point here to approach that point. Then it's the instantaneous rate of change. So we're going to find the limit as h goes to 0 of h plus 9, and that just equals 9. So that should have been your value.